So this video is going to focus on covalent bonds, the third type of bond we're going to talk about in this unit. And this is found in chapter 10 with your online book. This is chapter 8 on the PDF that I have referenced as well, just so you have some other resources besides just my notes. So chapter 10 on your online textbook, and chapter 8 is a PDF that I have provided to you. So for this discussion, it would be a good idea for you to have some kind of periodic table available to you. If you want to find that before you continue on the video, that might be helpful. So covalent bonds is the third type of bond. So we've talked about ionic, metallic, so covalent bonds. So covalent bonds is the sharing of electrons between two atoms, the sharing of electrons between two atoms. So the key word in this definition is sharing, okay? So we're going to talk a lot about sharing. Do the atoms share it equally? Do they share it differently? But we are going to be talking about sharing of electrons. That's going to be our definition. And these are what we call molecular compounds. So molecular compounds are going to involve nonmetals. So we're talking about the right-hand side of the periodic table. So with these molecular compounds, we don't spend too much time on it in the beginning of the year when we're doing naming, but we do have some molecular compounds that we have encountered. One in particular is CO2. CO2, carbon and oxygen, are both nonmetals, and they combine in such a way to make a molecular compound. They make covalent bonds. So please know molecular and covalent are not going to be interchangeable, but those are going to be two words that you hear used. So this is called carbon dioxide. Again, we did not spend any time on naming them or doing anything with them because, again, we kind of needed to know how they formed before we could do any kind of naming. So covalent bonds, because we are sharing electrons, we're going to be doing something called electron dot structures, Another way you might hear it is Lewis dot structures. That is, I think your online textbook uses that language. So realize that they kind of mean the same thing. We are going to be using dots to show valence electrons, because as I introduced this unit, valence electrons are the ones that get involved with the bonds. So it's not the innermost electrons that we are looking at. And for what we are going to cover in this course, we're talking about the S and the P orbitals. Are going to be those valence electrons. Yes, we will encounter some of those transition metals that I had you do some electron configurations of, but really what we're focused on is what we call the representative elements. So it's going to be the first two columns on the periodic table, the alkali metals and the alkaline earth metals. And then you're going to have the last 6 columns, including your halogens and your noble gases. So those are going to be, again, P1 through P6, and then S1 and S2. Those are going to be the ones we focus on the most for these. So what it means to draw a Lewis dot structure is to go, okay, well, how many electrons does it have in its valence shell? Another way you might hear it. So let's say I'm looking at something like calcium. So please remember, calcium is in that S2 column on the periodic table. So that means it has 2 electrons in the outermost energy level. So what you do is you write calcium symbol in the middle. And then you're going to draw 2 dots because it has 2 valence electrons. So 2 valence electrons, VE is sometimes how you see it abbreviated. So I'm going to draw 2 dots around calcium. So generally speaking, you're going to draw dots on every side of the element, and then you start to kind of double things up, but it really doesn't matter. So calcium has 2 dots around it, signifying its valence electron. What if we go over to the right? What if we do carbon? Carbon's a big one in a lot of bit of chemistry. Carbon is, again, in that 4th column. So you have 2s, and then you start to get into the p. So then you have 2 in the p at this point. So that's 4 valence electrons. So generally speaking, you're going to put a dot on each side to show the 4 valence electrons. Okay, and what's interesting about this is because these are what we call covalently bonded molecules that we're going to be drawing in some cases, these are going to be where the bonds form. Okay, Next door neighbor to carbon is our friend nitrogen. Okay, so it is in the P3 column. It's in the P3 column. So it's 3 in the P and 2 in the S. So if I write nitrogen, it's going to have a total of 5 valence electrons. So I'm going to draw 1 dot on each side, and then I start to double up. So I'm going to put the doubling up here on the top, but it really doesn't matter where you do it as long as you show the correct number of dots. So see if you could write chlorine, Cl's dot structure, pause the video and see if you get the same answer I do. So you should get chlorine has 7 valence electrons because it is one of the halogens. It has a P5, that's the P5 column. So that's 2 in the S and 5 in the P. So you have 7 valence electrons. So maybe it's occurring to you that there's a magic number. Okay, the magic number, as I talked about before, is called the octet. So I want 8 valence electrons around everything as much as possible. So chlorine is essentially missing 1 electron, and then it would complete its octet. So the magic number is 8. So when you look at things like the noble gases like neon are going to have 2 in the S and 6 in the P. Well, they have what we call the correct number of valence electrons. So they have, drawn it poorly there, I have 8 valence electrons around it. So there should be 2 separate dots, horrible drawing there. So neon, one of the noble gases, has what we call a complete octet. So these dot structures are going to help us to kind of assess, well, how many bonds is it going to make? How many electrons does it need to complete the octet? And so what it happens in a covalent bond is they share electrons. While in ionic bonds, we're talking about transferring electrons. So again, it's just going to be a little different. And so that's why we do electron dot structures when we do covalent bonds, and we try to keep it separate from ionics. So we're going to start to do some of these drawing of these molecules, but the foundation is understanding how many valence electrons you have. So to finish this up, molecular compounds, things with covalent bonds, okay, so put covalent on there as well. Covalent bonded molecules have interesting properties due to the fact that they are sharing electrons, So molecular compounds all have all states of matter. So they're gases, liquids, and solids. So they're not like ionics where they're just solids. Molecular compounds, covalently bonded molecules, have low melting points. And that again is due to the fact that they are sharing electrons. So it's a different force that we're talking about. And then they are poor conductors of electricity, So again, some examples, CO2, like I mentioned, water is considered a molecular compound in how it's bonded together. So what we're going to focus on is, again, with these electron dot structures, when we're sharing electrons, how do we make these bonds?